Okay, so for this lesson, we're going to be talking about quartiles and percentages or percentiles. So as you hear both words being used. So let's start with quartiles and we'll begin with a few definitions. So first, what is a quartile? So quartiles divide a set of ordered data into 4 equal partitions. These are 4 groups with the same number of data values in each group. Our quartiles are very similar to a median, and remember our median divides our data into 2 equal partitions. Our median is that number right in the middle, and we have an equal number of data points below that number and an equal number of data points above that number. Now, when I divide my data into 4 equal partitions, I do this using 3 different quartiles or 3 different points. So you'll notice here that we have our smallest data value down here on the left. So it is important that our data is ordered from smallest to largest. I have my largest data value over here on the right. Now, right in the middle, we have our second quartile. And this here is just our median. Just like our normal median that we've talked about for a really long time. That's our median, but we can also refer to it as the second quartile. It's actually mean the same thing. Now, what we do from there is to split this into 4 even pieces. I split this side into 2 with our first quartile, and I split this side into 2 with our third quartile. Now, in each of these partitions, we have a quarter of the data values because I split it evenly into 4 parts. So there's a quarter here, a quarter here, a quarter here, and a quarter there. Now, what we're going to do is we're going to go through and actually find the values of the quartiles. So here are the steps how to do it. We'll walk through the steps, and then we'll actually do a few examples. So the first thing we have to do is arrange our data set in order from lowest to highest, just like we would do with our median, right? The first thing we do is we arrange our data set lowest to highest. Then we just find our median, just like we always would. And this is our second quartile. So we'll find our median just like normal, and then we'll label it as Q2 or a second quartile. The one difference is that instead of just circling our median or saying our median is equal to whatever number, we're going to draw a line through the median. And now the values to the left are in the lower half of the data set, and the values to the right are in the upper half of the value of the data set. Then what we do is we find the median of the lower half. That's Q1 or our first quartile. Then we find the median of the upper half, that's Q3, or our third quartile. So those are the steps. Now what we're going to do is we're going to do 4 examples going through those steps just to emphasize them. Now you'll notice that these 4 examples are broken down into cases. So I will explain what each case means. You will not be expected to memorize the cases and know what each case represents, but it is important just to see the differences. No matter what case you're looking at though, all the steps are exactly the same. It's just a way for you to break down the different kinds of questions you could get. But you certainly don't need to remember which case is which. I'd never ask you a question like that. But I certainly could ask you to find your median and your first and third quartiles. So let's go through our steps. So for case 1, we have an even number of data points. So the first thing I'm going to do is find the median. So I start by verifying that everything is ordered largest to smallest, which it is. And then I'm just going to find the middle. Now the middle is right between 4 and 5 here. Now that is our median, but because we're talking about quartiles, we denote this with Q2. Now our median is the number right in between 4 and 5. So that would be 4.5. Now to find our first quartile, what we do is we look at all of the numbers on the left of our median or second quartile. With that data set, we're going to find the middle or the median of that half. So I'm going to split it in half down the middle, and that will be Q1. So Q1 is right between 2 and 3, so that would be at 2.5. And then Q3 is right here in between 6 and 7, which would be at 6.5. Now I just want to verify that I accurately split up my data into 4 even groups. So if I look at each group has 2 data points, so I'm all set and I've split it up properly. Now this case one was interesting because we have all decimal values. That won't happen all the time. Sometimes we will get whole numbers, and we'll have some examples of that too. So for case 2, now we have an odd number of data points. So let's find our median or our second quartile. So I first verify that they are all in order from lowest to highest. And then I find my median. So my median is going to be right here at 5, right in the middle. So I draw a line right through it, and that is my median. Then I'm going to find my first quartile. And now on either side of my median, I have an even number of data points, which means that my first quartile is going to have a decimal value, and so will my third quartile. And that's okay. It's just that's what categorizes this as a different case. So I look on the left-hand side and the lower end of my data, and I draw the median. So that is my first quartile between 2 and 3 at 2.5. Then for my third quartile, I look at the upper half of my data. So 6, 7, 8, 9. I find the median, draw my line through that. And that's my third quartile in between 7 and 8. So at 7.5. Then for case 3, I have an even number of data points. So let's find our median. So I start by verifying that everything is in lowest to greatest order, which it is. Now I find my median. So because I have that even number of data points, my median is not going to be a whole number. That's okay. So my median is right here between 5 and 6. So at 5.5. Then I look at my lower end of the data. So 1, 2, 3, 4, 5. Now the reason that this is a separate case is that I have an odd number of data points on either side of my median. So those will be whole numbers. So on the lower end, on the left-hand side, I split that right in the middle, and that would be at 3. And then on the right-hand side, I split it right through the middle, and that would be at 8. Finally, our last case. So now we have 11 data points. So it is an odd number, so we can assume our median will be a whole number. So I start by finding the median. So I verify that it is lowest to highest order, which it is. And then I find my median, which would be at 6. Now, this is its own separate case because I still have odd numbers on either side of the median. So I'll end up having all whole numbers, which is really great. So let's look at the lower end of the data. My median of the lower end of the data on the left-hand side is 3. So that's my first quartile. And on the right-hand side of the data, the upper half will be at 9. So those are the 3 different cases. The steps are identical. If looking at cases helps you, then great. But you can just approach them all in the same way. Just be mindful of the fact that you can have decimals, you can have whole numbers. Both are absolutely valid. And we'll do another example below just to practice that again. And one quick note here, quartiles are not intervals. They're just a data point, just like the median. But very often, people refer to them as intervals or data ranges. So within the first quartile, and a lot of people like to use those terms. So you'll hear those a lot day to day, but that's not really correct. What's really correct is that those are the intervals maybe between my first and second quartile, sure, but the actual quartile itself is just a data point. Okay, are there any questions about this before we move on to the next piece? Because they build off one another. So we just need to make sure that everybody's okay before we move to the next part. Any questions? Are we okay? All right. If anything pops up, just let me know. But let's move on to a couple more definitions. So the second definition that we'll talk about is what's called the interquartile range. And our interquartile range is often just referred to as our IQR. You'll see that written quite a bit, and that's just referring to our interquartile range. Now, the interquartile range is the range in the middle of the data. In other words, it's the distance between the first quartile and the third quartile. Basically, I'll just pop up here for a moment. We're looking for the range of this. How far spread out is this part here? Is that part really close together? Or is that part really, really spread out? That's what our interquartile range is telling us. So, in order to find that, I take my third quartile and I subtract my first quartile. And then what that tells us is how far spread out, how spread out the middle part of your data is. Now, similar to our standard deviation or variance, this is a measure of spread. How far spread out is our data? Is it really, really spread out, or is it all very, very close to the median? That's what we're trying to find out. That's what our interquartile range represents. And that's the formula. You'll be given that formula. That's not a super tough one. Now, we also have what's called the semi-interquartile range, and we often just write it out like this. Now, the semi-interquartile range is half of the interquartile range. So in other words, I can take my interquartile range and divide it by 2 to find my semi-interquartile range. So I can write it like that, or I could write it like this. My third quartile minus my first one divided by 2. Both of those mean the same thing and both represent our semi-interquartile range. Now, what does our semi-interquartile range represent? Why would anybody want to just divide it by 2? Our semi-quartile range is very similar to our standard deviation. It's basically how far away, so how far above or below the median is a data point. So our standard deviation says how far away above or below the mean is our data point. This same idea, just how far away from the median is our data point. So it's really, really similar to standard deviation, just the median instead of the mean. So the next thing we're going to do is we're going to do some graphing. in order to display this information, but we do need to be comfortable with our interquartile range and our semi-interquartile range before we move on to that next step. So are there any questions before we move on to the next piece? Okay, seems like we're okay. So we're going to quickly talk about graphing these, and then we're going to put it all together with an example. That way I can show you how everything is connected and how we can put all of those steps together. So when we're displaying this information, we use what's called a box and whisker plot. And box and whisker plots are done on graphing paper, and they're based off quartile values. And we'll go through, I'm just going to point out some of the key pieces here, and then we're going to go through and graph the whole thing together. So there's two main kinds of box and whisker plots, and they differ slightly. You do need to be mindful of which one is which, because on your quiz, you'll only have to draw one of them, and you just want to make sure you draw the right one. So first, we'll look at just our standard box and whisker plot. So we have our smallest data value on the far left side. And then we have our greatest data value on the far right side. Now, the other pieces that we want to denote are our first quartile, our second quartile or the median, and our third quartile. Now, just like before, our interquartile range contains half of our data points, right? Because there's a quarter of them here, a quarter of them here, a quarter of them here, and a quarter of them here. So in that little range has half of our data points. So what this helps us to do is to see where half of our data points are living. Is our little box where half of our data points are really, really small, or is it really long? It also helps us to see how far away our greatest value and our smallest values are from that box with half of our data in it. So that's our first plot, and we will draw one of those together from scratch below. Then we have our modified box and whisker plot. So this is the other one that is slightly different. Now, this type of plot takes into account when the data contains outliers. So we'll draw it slightly different to account for these outliers. Now, when we're working with a box and whisker plot, I want to actually identify whether or not a data point is an outlier. For your project, you don't need to go through the process of actually determining this information. If it's just way higher, you can count it as an outlier. But here we actually want to go through and determine specifically if one is an outlier or not. In order to do that, we have to define an outlier. So an outlier is a point that's at least 1.5 times the interquartile range. So if it is 1.5 times the interquartile range away from the third quartile, it's an outlier. If it's below, it's an outlier. And I'll show you how to calculate those pieces. So when we find those outliers, what we do is we graph them on their own. So we graph them far away. They just live by themselves somewhere else. And then we graph everything else the same, just without those 2 points. So those outliers are now just not included in our graph anymore, and we graph everything else the exact same. Now, what I want to do is I want to go through an example that explains all of this and puts it all together just to make things very clear. So unfortunately, this didn't appear here. So let me just quickly write it. So it should say some students in grade 12. That's what it should say. Sorry about that. There we go. So some students in grade 12 were surveyed to find out how many plates of fries they eat per month in the cafeteria. And these were the following results. So we have 5, 2, 15, 1, 4, 1, 25, 1, 4, 0, and 10. So what we need to find is our median, first and third quartiles, interquartile range, and the semi-interquartile range. So we're going to find all of the possible information. So let's work on finding the median first. We find the median like we've always found the median. So the first thing we have to do whenever we're finding the median is we have to put the data in order. That's the first thing we have to do. So as I put the data in order, I just like to cross them off the list just so that I can keep track that I haven't missed a number. So we'll have 0, 1, 1, 1, 2, 4, 4, 2, 4, 4, 5, 5, 10, 15, 20. And we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So I've ordered our data. And now let's find some of these key points. So we want to first find our median. I have 12 points. So my median will be in between two numbers because this is a even number of points in our data set. So I go and I find my middle for my median. So remember, my median can be referred to as Q2 or my median. And this is right between 4 and 4. So my median is 4. Now we want to find our first quartile. So we found our median. Let's find the first quartile. So now I look at the data on the left-hand side, and I want to find the value that's right in the middle. So that would be right here. There's our first quartile, and it's between 1 and 1, so it's at 1. So that's our first quartile, and now let's find the third one. So I look at the data set on the right-hand side of the median, and I put my line through the middle. Now, this is between 5 and 10, so I want to find the number that's right in between 5 and 10. Some people can do this in their head, but if you're unable to, what you can do is we take 5 and add 10, and then we divide by 2 to figure out the number that's right in the middle there, which would be 7.5. So that's our third quartile. And then I want to verify, did I split it into 4 even sections? So there's 3 points in the first interval, 3 points in the second, 3 points in the third, and 3 points in the fourth. So I split it up correctly. The next thing that I want to find is my interquartile range. Once I've found my quartiles, my interquartile range is very straightforward to find. So to find my interquartile range, I'm going to take Q3 and subtract Q1. Just like that. So Q3 is 7.5 and Q1 is 1. So our interquartile range is 6.5. So that's the interquartile range. 50%, or the middle part of our data, is 6.5 away from each other. So there's a range of 6.5 there in the middle of our data. Finally, we want our semi-interquartile range. And remember, to find that, we just take our interquartile range and we divide it by 2. And that will give us 3.25. That's our semi-interquartile range. Okay. So that is all of the information we need to find first. Next, we're going to draw the box and whisker plot. Just our standard box and whisker plot. No need to worry about outliers just yet. Just our normal box and whisker plot. So when I draw a box and whisker plot, the first thing I want to do is work on my scale. So all of my data points go from 0 to 20. So I want to ensure that all of those are included in the scale. So I'm just going to write my scale like this. If you wrote it slightly different, that's totally okay. There we go. And I also want to label it. So this here is representing our plates of fries. That's what that is representing, our plates of fries. So now when I draw a box and whisker chart, I'm going to start by marking my lowest and my highest values. So my lowest value is 0. So I'm just going to put a line there to represent my lowest value. Then I'll do the same with my highest value. So my highest value is at 20. So I'm just going to draw a line to represent my highest value. Then what I do is I want to mark down my quartiles. So we'll start with our first quartile, which was at 1. Now I'm going to make these lines bigger because this is going to form the box, just to make things a little bit easier for ourselves. Then our median is at 4. So I'm going to mark down the median. And our third quartile, or Q3, is at 7.5 here. There we go. And I do want to label those. So we have Q1, Q2, and Q3. And now I can finish up my box and whisker plot. So I go and I make this into a nice box with my interquartile range here, just like that. And then I'm going to draw the whiskers all the way out to my smallest and biggest points, just like that. And that is our final box and whisker plot. That's all there is to it. So once you have those values all figured out, drawing the graph is very, very simple. Are there any questions at all before we move on to the next bit? Okay. Doesn't seem like there are, which is awesome. So we're going to draw another box and whisker plot, but this time we're going to draw a modified one. So we're going to take into account the outliers. So the first thing we're going to do is we're going to check for outliers to see if there are any outliers there. And then if there are, we're going to draw our modified box and whisker plot. So let's start by looking for outliers below our first quartile. So we're going to look for outliers below Q1. And I just want to walk you through the whole process of how we find the cutoff for these outliers. So to find our outliers below Q1, we take Q1 and we subtract our IQR multiplied by 1.5. Just like that. Now this is going to give us the cutoff of where our outliers start. So anything below this number we get will be an outlier. So I take Q1, which was 1, and then my IQR, which was 6.5, multiplied by 1.5. So that will be 1 minus 9.75, which gives me negative 8.75. So any numbers that are smaller than negative 8.75, those would be considered outliers. So what I do is I look through my data and I see if there's any data points that are below negative 8.75. And in this case, nope, my lowest is 0. So because there's no data points smaller the negative 8.75, I can say, therefore, there are no outliers below our first quartile. We'll have to check the other side, but no outliers below Q1 at least. That's what we've determined so far. Now we'll do it again on the other side. So let's look for outliers above Q3. That's the next thing that we'll do. So I take my third quartile, and now I'm going to add my IQR multiplied by 1.5. This will give me the cutoff, and then any numbers above this would be considered outliers. So we'll have our third quartile is 7.5. And then we have our IQR, which was 6.5, multiplied by 1.5. So that will give us 7.5 plus 9.75. There we go. And when I put that into my calculator, I should get 17.25. So any number in our data set greater than 17.25 will be an outlier. 17.25 is the cutoff. So I look at my data set, any values bigger than 17.25, and there is. 20 is an outlier. So I can say, therefore, 20 is an outlier. Now, one important thing to note here is that if I look at my original box and whisker plot before we've dealt with outliers, look how far the whisker is on the right-hand side. Our interquartile range is very far away from that greatest data point, so it's likely that we will have an outlier in situations like that. Okay, so now let's draw our modified box and whisker plot. So I'm going to start the same way by drawing my scale. I still need to go from 0 to 20 because I still need to include all of those data points. So I'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I also want to label it again. So we have plates of fries, just like that. This time around though, I'm going to start by plotting my outlier. So my outlier is at 20, and it's just over here. I'm just going to start by plotting my outlier. And now I'm going to graph everything else exactly the same, but as if 20 wasn't there. So I start by adding in my smallest value, which is still 0. Now for my greatest value, we're pretending 20 isn't there. So my next greatest value will be 15. So this here is going to be our highest value, but without our outlier. So we're not including 20. Then in terms of graphing our quartiles, it's the exact same. Our first quartile was at 1, the median is at 4, and our third quartile is at 7.5. Like that. And then I just draw my box around my interquartile range and draw the whiskers as well. Now I want to make sure that I label my quartiles. So we have Q1, Q2, and Q3 over here. So that would be our modified box and whisker plot because I've accounted for that outlier there. Are there any questions about that at all? Okay, doesn't seem like there's any questions, which is great. So we have one more small piece to talk about. We're almost done. Okay, so the last thing we're going to talk about are percentiles. And percentiles divide a data set into 100 equal partitions or 100 groups of equal size. So it's very similar to quartiles and the median. So instead of splitting it into 4 even groups like a quartile, or splitting it into 2 even groups like a median, we're just splitting it into 100 even groups. So just small little groups. Now I'm just going to briefly read through the steps of how we determine percentiles. These are not the steps to answer the questions below. It just gives you a sense of what's going on when I'm setting up my data for percentiles. Then we'll go through a couple of examples that will outline the steps in how you approach these kinds of questions. So how we determine percentiles is we first start by arranging our data set in order from lowest to highest, just like we've done the whole time. Then we're going to group these into 10 subsets of equal size as best as we can, right? Because we're grouping them into such small categories to have 100 equal groups. Sometimes they're not all equal, and then we'll account for that below. If the groups are of all even size, then the 10th, 20th, and 30th percentile will be an average between the last value and the previous group. So if we have even numbers, just like we were doing before, we have to make sure that we're averaging out the data value we get and the one above it. I'll show you what I mean in a second. And then to find an individual percentile, such as the 34th percentile, we're going to repeat the procedure using different subsets. Now, that's a little bit confusing, so I'm going to break it down how to actually work through these and make sure it's nice and clear. So we have a class of 40 students, and here are their marks on a test. The data has already been sorted for us in ascending order, and it's been arranged into 10 even groups. So we've arranged it into groups that are even. And very often you'll find that we're arranging them into 10 groups just because that is a good number and that's really as small as we can get. And that will still work with 100. Then what we're going to do is we're going to start by finding the mark at the 50th percentile. So I'm just going to grab this and paste it here so we don't have to keep going over to the previous page. So we want to find the mark at the 50th percentile and then determine how many people received that mark. So here's how we approach these kinds of questions. We're looking for the 50th percentile. That 50th percentile is what we call an index, the 50th. And we're going to use K to represent this and to be able to work with it. So we're looking for the 50th percentile. So K is going to be equal to 50%. Now we also want to take into account how many data points we have. So N is going to represent our number of data points. In this case, we have 40 data points. That's what it says in the question. Now we want to figure out which number would be represented at our 50th percentile. So which number would be represented at the 50% mark in our data? To do that, we take our number of data points and multiply it by the index. Now you may be thinking to yourself, oh, 50% of 40 is 20. And you're right. That's why we multiply them. But this way you can understand the steps if we're dealing with any percentile number, not just 50. So that means 20. Now here's what happens with percentiles is just like before, anytime I have an even number, That makes my line land in between two numbers. When I multiply n and k, if I get an even number, I have to average two data points. So how this works is I'm just going to make a note so you can write that down. So since we get an even number, from nk, what we have to do is we have to find the average of our 20th and 21st data points. Now, if we had an odd number here, we could just use that data point. But because whenever we have an even number, it lands in between two data points, we just need to take that into account. That's what we're doing. So let's find our 20th and 21st data points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20, and here's 21. So that's our 20th data point, and that's our 21st data point. So we find the average of those two. In this case, they're both the same, but I want to go through all the steps just so you could approach it for any numbers. So we'll find the average of them. So we add them together and we divide by 2. So we'll get 68. So what does this mean? What it means is that therefore the 50th percentile is 68. And then we look to see how many students have that mark because that's what we were asked for in the question. And I look and 2 students had that mark. 2 students had that mark. Now, the questions that you would get on an assessment would be a very similar style to this in terms of percentiles. You'd get your data set. These would also be large data sets, so it would already be organized for you, and then you could approach it in the same way. Any questions before we move on to our final example? We're okay? All right, let's do one more example, then that's it. So this last one, I'm just going to quickly paste that chart down here again so we don't have to keep scrolling up. So the question is, does a mark of 85% on the test place the person's mark at, above, or below the 85th percentile? So we're looking for the mark at the 85th percentile, and then from there we can determine whether or not the mark of 85 is above, below, where it sits. So let's find this 85th percentile. So that would mean that our K value is 85%. And then we still need N, our number of data points, and we still have 40 data points. That hasn't changed. Then we need to find NK to figure out which data point we're looking at. So we'll do 40 multiplied by 0.85, and that will give us, 34. Now, just like last time, because we have an even number when we multiplied NK, we have to take the average of the 34th and 35th data points. Just like last time. So let's figure out which data points are the 34th and the 35th. So we have 4, 8, 12, 16, 20, 24, 28, 32, 34, and 35. There we go. So we need to take the average of that. 85 plus 87 divided by 2 would be 86. So the 85th percentile is sitting at 86. So that means that a mark of 85 would be below the 85th percentile. Because the 85th percentile is 86. So that mark would be below. So these ones get a little tricky for sure. The more you practice them, the better you get at them and recognizing which question it is. But one quick note about percentiles before we get into the homework is that because the percentiles divide a data set into 100 partitions, there's actually only 99 percentiles, not 100. So just like with our quartiles, there's only 3 quartiles, right? Q1, Q2, Q3, because we're splitting into 4 sections. Exact same idea here. So there is a little bit of homework. Actually, no, there's a lot of bit of homework, but this is really good practice for you for the quiz on Wednesday. So the homework is going to be page 148, number 6 BCD, 7 BC, 9, 10, 11, and 14.